Hello, in this lecture we will consider the AC circuits containing only resistance, inductance and capacitance. Today we will discuss the AC circuits containing only resistance and inductance. Now let us start with the AC circuit with a pure resistor. R is a resistor which is connected with a alternating source of EMF E equals to E naught sine omega t. So the EMF appears across the resistor is E naught sine omega t. You know very well that I is equal to E upon R. So current equals to E naught sine omega t upon R, which can be written as I naught sine omega t, and say it is the equation 2. Now when you compare the equation 1 and equation number 2, see here is a sine omega t in both the cases. It means the current and the potential both are in the same phase. There is nothing is leading, nothing is lagging. Both are in the same phase because the factor is omega t. Second, I naught is equal to E naught upon R. Now, how to represent this current wave and the potential wave? As both are in the same phase, so both are going up and down with the same time. So we can say that the current and voltage both are in the same phase. This is represent the peak value of the voltage. This represents the peak value of the current. It is the equation of the voltage. This one is the equation of the current. Now the phasor diagram. Phasor diagram is the pictorial representation of the current and voltage. Or we can say the representation of the current and the voltage in the form of vector called phasor. This phasor rotates in anti-clockwise directions. Now it is a voltage phasor and this angle is omega t. This length is represents the peak value of the voltage, that is this one value, this value, that is the peak value. This length is equal to the peak value and its projection on this axis, on y-axis, gives the instantaneous value. Similarly for the current, now see, this length, red color length, represents the peak value and the projection on the y-axis gives the instantaneous value of the current. It is the instantaneous value of current and this angle is omega t. So it is a phasor diagram. Now the AC circuit with a pure inductor. As you know, it is a solenoid or it is also termed as inductor. The alternating source of EMF is connected across this inductor. EMF is E naught sine omega t. Now, induced EMF is equal to minus L into di by dt. As you know, it is an alternating EMF and the magnitude of the current through the solenoid changes continuously. As a result, EMF is induced which opposes the change in the current and it is called induced EMF and this value is equal to minus L into di by dt. When we apply the Kirchhoff's law on this loop, then E minus E equals to 0, or we can say E equals to E, or in other words E equals to L into di by dt. Now to make it clear, I will draw this. Okay. Now it is equals to L into di by dt. In place of E, put this value E naught sine omega t. This can be rearranged. Di equals to E naught upon L sine omega t into dt. The current is obtained by integrating this whole. Okay, as you know that the integration of the sine omega t is equal to minus cos omega t upon omega. So this can be written as in this way. As you know, we can change it as sine omega t minus pi by 2, where I naught is equal to E naught upon omega L. When we compare this expression with Ohm's law, we see that omega L plays the same role in inductive circuit as played by the R in resistive circuit. This omega L is called inductive reactance. This omega L is called inductive reactance and is represented by this symbol. As it plays the same roles, so its unit is also same as that of the resistance, that is ohm. When we compare the equation number 1 and equation number 2, we have seen that in case of voltage it is sine omega t, in case of current it is omega t minus pi by 2. It means in case of the inductive circuits, current lags by the angle of 90 degree than voltage. Current lags behind EMF by 90 degree. Now the waveform. Now as the red color represents the current and the blue color represents the potential. And you have seen when the potential is zero, current is maximum. When potential is maximum, current is zero. So there is a phase angle of pi by 2. Now the representation in the Phasor diagram. It is a representation in the Phasor diagram. It is a potential which leads the current by the angle of pi by 2 and it rotates in an anti-clockwise direction. So we are taking the current in the fourth quadrant. And the angle between the current and the voltage is 90 degree and this angle is omega t. It is a peak value of the voltage and this projection, this value is an instantaneous value. It is the peak value of the current and its projection gives the instantaneous value of the current. Thank you.